So your question, I told you that please go in the channel, and already we have discussed on that problem. Okay. So now, okay, again I will discuss this question. It has come in mechanical 2020, and he is asking which one of the following complex function fz is not analytic at all point. Okay. So they are asking, please discuss more. Okay, no problem. I will discuss. I will give you one trick, very smallest trick. So to check the analytic function, some people use the CR equation, necessary condition. No need to check the necessary condition. Okay. Why you will use the CR equation here? Number first is e to the power z. The graph of e to the power z is this. This function exists. You know that e to the power z, e to the power z, e to the power x. Suppose we are using e to the power x. Y is equal to this. So dy upon dx is equal to, again you have e to the power x. So this function is differentiable everywhere. You can see. The best one is you have to check where the function does not exist. So this function exists everywhere. There is no problem. So this function is analytic. No problem. Now the second one, sin z. Okay. The function sin z is equal to this. Sin 0 is equal to 0. This is your function. This is 0 and this is pi by 2 and this is pi. Okay. This is 3 pi by 2 and this is 2 pi. So you can see that everywhere this function is exist. How to know that a function is not differentiable at any point? I have given you the shortest trick. If there is any cusp, any corner in the graph, then you will know that this function is not differentiable. Just the example is y is equal to x mod. So this function is differentiable everywhere except 0. At 0 there are two tangent. You can see that the direction of the tangent are two. One is going here and one is going here. Okay, so there is a cusp. Cusp means a corner, such type of corner. If there is any such type of corner, then you will say that such type of differential equation, such type of function is not differentiable at that point. So this function is differentiable everywhere but except at 0. At 0 this function is not differentiable. I will give you one shortest trick. Also last time in GATE exam they have asked this question. Y is equal to x power 3. This is differentiable or not? Okay, they have asked. I will give you one trick. Y is equal to x mod odd. Okay, this is not differentiable. Such type of function, if power is odd, such type of function is not differentiable. Is discontinuous manywhere. Okay, so this such type of function is not differentiable. So yeah, this function is not differentiable at 0. No problem. Okay, so such type of function is not differentiable everywhere. You can say. Okay, so if the power is even, then this function is differentiable. No problem. If y is equal to x even, so this function is differentiable. No problem. So here we are just talking about the complex analysis. So the sin z, this is also analytic. No need to just check the CR equation, okay, or partial derivative. Okay. Now the next one, we have written z square. This is analytic or not. Remember, every polynomial function is continuous, is differentiable, is analytic everywhere. All the polynomial means this is also polynomial. F of z is equal to z. All the polynomial is differentiable, is continuous, is analytic everywhere. Okay, so this is also analytic. So 3 where I have discussed, so it means that this is your false statement. Okay, but here also I will discuss why it is a false statement. Okay, so at first I will erase it you must go play with graph. Already we have discussed how to draw, how to plot the graph. You must go there. Okay, so INZ means log. The graph of log x is equal to this. Log x is not, you can say that if I will write negative, so the log function, it will not give you any, it will not give you any output. Okay, if you write negative here, then it is not exist. Okay, so it will exist only for the positive number, but at 0 it is going to infinite. At 0 it is going to infinite. It means that at 0 this function is divergent. Okay, so this function is not differentiable at, you can see also this function is not differentiable at this. You can think, okay, because this function does not exist at 0. We don't know about 0 at 0. Okay, so this is not analytic at 0. Okay, so this is your wrong answer. Okay, now second question, multiplication of the matrix. You must note how to multiply of matrix. Okay, if you have matrix, how to add, how to multiply. If you have a m into n matrix, and suppose you want to multiply another matrix and its order is n into m, then you can compute, because this and this must be same. If you will compute, then you will get AB means this is C suppose, and this is m into m matrix. Okay, so this is a way to multiply. And how to add? If you have two matrix, one is m into n, means m row and n column. So if you are computing with another matrix, then it must have also m into n, means m row and n column, means both have same symmetry, means same number of column and number of row. So but here it must be just mirror. It must be just like mirror. This is m into n and this is n into m. Okay, if you have a square matrix n into n, then there is no problem. Okay, so you have to remember this, how to multiply and how to add of two matrix. Now he is asking multiplication of the real valued square matrix of same dimension. They have written same dimension. If you have same dimension and you are multiplying two matrix, okay, square matrix, square means n into n. Okay, then first one is commutative. If you have one matrix A and this is n into n, and second matrix B, this is also n into n, because both are square matrix. Square means n into n. Okay, and it is commutative. You know that it is not necessary that A into B is equal to B into A. For the matrix multiplication, A into B is equal to B into A, that is not possible. Okay, it can, maybe it can commute and maybe it cannot commute. So this is not the necessary and sufficient condition. So this is wrong. Now second one is always positive definite. If you are multiplying two matrices, then it will give you positive definite. What is the meaning of positive definite? If the all eigenvalues are positive, then that such type of matrix is the positive definite. If you are multiplying two matrices and it is not necessary you will get the one matrix and its all eigenvalues are positive, or principal diagonal element. Okay, just leave it. This is sufficient for you to find the, if all the eigenvalues are positive, then such type of matrix is the positive definite. Already we have discussed what is negative definite matrix, positive definite matrix, semi-positive definite matrix, and semi negative definite matrix. We have already discussed. You must go there. So now this is also not necessary condition. Okay, you will get positive definite matrix. Now the third one is not always possible compute. Means you know that if both are square matrix, so you can multiply. If this is also a square matrix and this is also a square matrix, then you can compute, no problem. I told you, for multiplication you must have just like the mirror image of order m into n and n into m. But here that is the square matrix, so you can compute, no problem. So there is no such type of, if I will write A 2 into 3 and B 1 into 4, so you cannot compute in this condition, because here the order are different. These are not in mirror image. Okay, so but here both are same, so you can compute. So that is also wrong answer. Now he is asking not always possible compute, but it can compute. Okay, so this is wrong answer. And always positive and not necessary, and commutative not necessary, and associative, yeah. If you have two matrix, okay, A, B, C, what is the meaning of associative? Okay, so what is the meaning of associative? Associative means A operation B operation C is equal to A operation B operation C. Means either you will compute at first these two matrices, then compute with C, and or if you will compute two matrices and after then compute with A, then you will get same result. You know that in integer 2 into 3 into 4 is equal to 2 into 3 into 4. Same thing also for the matrix multiplication. There is no problem. Either you will multiply this 3 into 6, 6 4 is 24, or 4 3 is 12, 12 into 2 is equal to 24. You will get the same result. Similarly, for the matrix multiplication, if you will compute anyone, you will get the same result. There is no problem. Okay, so that is the correct answer for the matrix multiplication. I think that you understand. Okay, so next I told you that we have solved many problems. Now the last message I have come. Bhumika from Pantanagar, she is asking that please talk about the correlation and correlation and covariance. I told you I have already uploaded one series of statistics. You must go there. I have given you many examples. Okay, that examples also we are using in our real life. You must go there. Okay, no problem. I will also solve this question. It has come in the mechanical branch 2020. Okay, so we will start the next question.